good morning, good afternoon, good evening, good night, good all of the things to all of the continents, including but not limited to Asia, Europe, North America, South America, Africa, Australia, New Zealand, Antarctica. Anything else that I missed, feel free to correct me in the comments when you see this later on. I'm still waiting for people to join, so this is my little moment of peace where I can say my piece, my little spiel at the beginning of the live. So hello, 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 and welcome to yet another live stream episode of Baji the Handsome Cat, hosted by me, myself, with you. And I do hope to meet many, 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 many of you tonight, both new people and old people. And please do put anything you want in the chat, in the messages. I will read these messages and I will read out your usernames, give you a shout out and things like that. I'm hoping to see some of my newer friends, as well as brand new friends, as well as old friends, as well as really anybody. So thank you so much for joining in advance. And if you're seeing this as a video upload live stream under the live tab of my channel later on, and wanting to comment and leaving your comments and whatnot, then I'm extremely thankful and want to say thank you already for that. Thank you so much, Heike. I see all your comments and I really like it. I know it's a little bit late / early in Finland. So for example, my friend in Finland likes to watch the live stream episodes later on in his own good time and then leaves the comments, and I usually wake up to these comments by the time I'm getting up and out and about in North America here. These comments are ready for me. So thank you so much. If you see this live with me here tonight, we can hang out and go through the full episode together, or if you see this later on as a video upload under the live tab of my channel again, then thank you so much for that as well. Welcome to the live. Hello, 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 hello. See, as soon as people start to join, I try to go very quickly. My hair is a mess today, but I try to go very quickly and read everybody's comments and hang out and chit chat and see your usernames. Hello, El Challen, and shout out everybody and shout out your comments and whatnot. Hello, Kahil. You might want to be better behaved than that, because once my mods join, they will make sure that you are banished from this live if you're misbehaving and saying weird, awful things and being extremely rude. And I want to question who raised you, and or why didn't they, in fact. So hello, El Challen, how are you doing, my friend? El Challen says ciao ciao ciao. Chris says hi. Hello, Chris. Hello, Poyo. Says ban that guy. Well, you know, I'm not gonna bother. I think my mods will be here soon and they can do it. Nagaraju Jaka Nagaraju says nice, beautiful hair, super madam. Thank you, Nagaraju. Tonight I didn't shower or go to the gym or wash my hair, so it's a bit of a messy mop. Nagaraju says hairstyle is good. Oh, thank you. Gladys says hi. Hello, Gladys. Hello, Nagaraju. Hello, Chris. Hello, Poyo. Hello, everybody. El Challen and everybody. What are the qualifications for someone to become a moderator? Well, generally, thank you so much for liking the live. Can we get 10 likes? Can we get 13 likes? Can we get 20 likes? That would be most amazing. Could we please like the live while you're here and hanging out and chit-chatting? So the qualifications are basically the people who come to the live very often, or they come and they ask a lot of questions, and then I gather that they're very interested and curious and want to keep engaged, keep on being engaged, and so that's why that's how they become a mod on the channel. So generally they show a lot of good faith, goodwill to interact and engage and such, and that's pretty much it. There is not a lot more than that, but I will say that a lot of the mods here are very nice, kind people. They have been very helpful, and some of the more engaged audience members, really. Also, may I ask what the channel is about? What do you talk about? So I talk about cats and physics, lies. El Challen, is this because you want to be a mod? So, the channel is Cats plus Physics, including but not limited to astrophysics, cosmology, astronomy, physics in general, and things like that. So I make a lot of shorts on um, kitty cats to show the kitty cat lifestyle. And then on the lives, really what I cover is physics topics and cosmology topics and astronomy topics and astrophysics topics like stars, supernova, black holes, the universe. For example, right now we're covering this book called A Brief History of Time by Stephen Hawking, very famous book. It has sold a lot of copies. It even has a 10-year anniversary edition that we're covering from actually right now. And we're on the topic of time right now. So we have covered we're quite far into the book at this time. And right now we're in a chapter called The Arrow of Time and the Meaning of Time. So that's what we'll cover tonight as the topic. Are you aware of Neil deGrasse Tyson? Of course I'm aware of Neil deGrasse Tyson. He talks about cosmology, star stuff, stardust, things like that. So that would make sense. I think our topics are very overlapping. And he's very famous. So, of course, I know him, Neil deGrasse. But I will say the nice thing about this channel is one of the unique things is that we spend a lot of time on these topics. So it's not like a rushed TV episode where you see a thing and you can't ask questions or you can't interact directly and have your queries be kind of addressed throughout the live. So pretty much we go live on most nights and we cover these topics, and pretty much it's sort of like anybody who joins and has interest or curiosity about these topics can ask a question, and I try to answer it in real time during the live as best as I can, or I point you to the right direction, hopefully. And really your question could be anything from physics, anything from astronomy, astrophysics, and if I don't know, generally I'm able to kind of look it up. And I also have some textbooks with me that I heavily reference. One of them is, of course, this textbook that I have not been using. Well, actually, I used it recently, but there was a time when I used it a lot. Like almost every day we were doing something, and this is called Foundations of Astrophysics by Barbara Wrighton and Bradley M. Peterson. So things like that. And also we have something like this book. It's a more popular science book, Elegant Universe by Brian Greene. So we really, it's sort of a booktuber, book talk, booktube channel, but the topics are generally specific to physics, cosmology, astronomy, and astrophysics, and also our spirit animal is a cat. So there's Baji the handsome cat, and his siblings also appear on the videos. So that's really what's going on here. Thank you so much for being in the live. Thank you so much for coming to the live and asking these questions, and hopefully you will keep on asking more and coming to the lives more and get the drift of what's happening here. So with that, any other questions before I get started on the... I'm subscribing. This is legitimately the coolest channel I've come across on YouTube live streams. Do you only read the book mentioned, or do you also just have discussions? So it's both. We read the book and we have discussions. So sometimes when we're reading these topics, they're actually quite complicated, right? It's almost like we read the sentence and then we break it down a little bit, depending on the sentence. Now, I don't break down every single sentence that I read, but oftentimes we're reading the book and we are sort of bringing some insights of our own into the topic, into the discussion. So we heavily discuss the books, the topics. Sometimes we're reading more and sometimes we're discussing more, but generally I will try to break it down and bring my own insights into the topic with my own background in physics. Now, I'm not an expert in every topic of physics, but pretty much from what I do know and from what I have worked on, I'll try to bring those insights into the topic as well. And if it's astronomy, astrophysics, and cosmology, then I do have experience working on those topics, and so I do bring those types of discussions into the live stream as well. So tonight, without further ado, I might just get started with today's topic, which is the arrow of time. And yesterday, so last night, we started the topic. We finished up origin of the universe and fate of the universe, and we started to talk about the meaning of time. Now, Stephen Hawking mentioned that there's really three types of meaning of time. One is the entropy way, or the second law of thermodynamics way of looking at time. This is basically the way in which the arrow of time. Also, when I say time here, and I think I named the live stream meaning of time, really what I mean is arrow of time. In which direction is time kind of flowing, and how do we understand that? So one meaning of the arrow of time is really the thermodynamics meaning. The second law of thermodynamics says that entropy always increases. So you go from a more orderly state in the universe to a more disorderly state. So for example, if you have a cup of tea and then you spill that cup of tea and all of the pieces of the cup is on the floor, or the tea is on the floor, the cup of tea spilled and the glass piece is broken, or the cup piece is broken, is the more disorderly state of that particular thing. And so that's really where entropy has increased, and the arrow of time is going to be in whichever direction the entropy increases or the disorderliness increases. So it's not that we see things where the cup of tea that was broken, spilled, and pieces on the floor goes back to being an orderly cup of tea. That's not really what happens. We see the other way. We experience the other way, where we had an orderly cup of tea, but then it may just fall, break, splash, spill, and make a lot of pieces of that particular cup that broke. So this is the sort of understanding of entropy and the understanding of second law of thermodynamics that comes into play when we think of arrow of time in this way. This is the thermodynamics way of understanding the arrow of time, if you're wondering. The other way for the understanding of time, or the meaning of time, is a psychological arrow of time, where we remember the past, but we don't remember the future. So in physics, there are certain symmetries. We talked about these as well, actually. These are the C, P, and T symmetries. We won't get into it a lot right now because we did cover this last night. But basically, this is to say that there was no reason for us to only remember the past and not the future. If things can happen in this direction, things can also happen in that direction. If the past is known to us, unless we have, of course, some kind of memory loss, then the future could and should also be known to us. But this is sort of the point where our psychologically we only understand and we only remember the future, or sorry, we only remember the past. We don't remember or see the future. Sometimes we say hindsight is 2020. That's all of that is to say that we understand and remember the past and not the future. Hello, Nathan. How are you? Thank you for being here. I'm glad to see you today. Glad to see you tonight. Thank you for coming. My hair is more disorderly today. I guess the entropy example applies to my hair tonight. But that's basically the first two ways of understanding the arrow of time. So entropy way and the psychological way. Thank you so much for being in the live, and thank you for liking the live. The third way is the cosmology arrow of time. So this is going to be very interesting and related, of course, to the topics that we discuss here. The cosmology arrow of time is the arrow of time, or the directionality of time, that allows our universe to expand. So we know that that the universe is expanding. Now, we've talked a lot about, the beginning of the universe, the Big Bang, how that's a singularity, how really the definition of time doesn't make sense before the Big Bang, unless we have a religious or a spiritual reason for having some conception of time. Really, time starts when the Big Bang happened and when the universe got started. But as far as the arrow of time goes, how do we know in which direction time is pointing, if you will, if there's an arrow of time? Well, in cosmology, the definition is that the universe has been expanding ever since the Big Bang. Now, the rate of expansion, what that rate is, what it should be, what we think it is, how much we measure it to be, and how much that kind of affects other things in the universe, like cosmic ingredients, which we've talked about as well, cosmic inventory, which of course includes but is not limited to dark matter, dark energy, things like that. Those are the details, but we do know that the universe has been expanding. So if you say that the universe is contracting, then the arrow of time is backwards. If you say that the universe is expanding, then the arrow of time is forwards. So those are the three ways in which we can understand a meaning of the arrow of time. And we will see further what Stephen Hawking has to say about this. And he's going to take us through some arguments here in the chapter called Arrow of Time in his book, A Brief History of Time, where he talks about how these three ways of looking at the arrow of time might just come together, might just have a bit of a conjunction here. Nathan says, I've missed you. Hi, Nathan. I missed you. How was the camping on the weekend? I saw your comment saying that there was camping to be had on the weekend, and that's why you would miss my lives. But actually, I did not really go live on the weekend myself. So you didn't miss much on the weekend, but we did go live last night kind of late. So you missed that one, and we talked about the origin and fate of the universe, and we wrapped up that particular topic, and we started this new topic called the Arrow of Time. We're still covering Brief History of Time by Stephen Hawking, though. So thank you so much for being here, and tell us more about your weekend. Dora Madness says, I can't hang for long, but let's get 20 likes. Yes, can we get 20 likes? Boyo says, unrelated question, but who do you think is the most important scientific mind in history? It's Newton. Nathan Mullins says, it was great fishing and kayaking. Wow, fishing and kayaking. I kind of want to kayak. I don't know anything about fishing, but kayaking sounds really nice. So Isaac Newton, I would say, is probably the most path-breaking person in physics. He did a lot of things like gravitation, optics, calculus, So his contributions, and he wrote the Principia. So I would say because he both did a lot of work and he documented it in a very nice, good book, series of books, I really appreciate that. As somebody who likes books, and as somebody who likes and believes in documentation and believes in prolific contributions, I like when somebody is so dedicated that they're very prolific, not because they have some pressure on them, but because they just have so much time and curiosity that they just contribute forever more and more and more. And that's exactly what Newton did. He was very introverted, very alone with his dog, right? He had that life of like just freely flowing and contributing endlessly to the topics that he was curious about. And I really liked that. And he wrote the Principia. So he invented calculus independently from the other guy who did that too. He worked on all these physics topics, the gravitation, the laws of motion, laws of gravitation, classical mechanics basically, and optics and light and whatnot. So for that, I think that Newton is really, really good. His nature was very, very different than, of course, the other person that comes to mind, which is Einstein. Einstein was very outgoing as compared to Newton. He was charismatic, was able to, had very good oratory skills, had very good skills of communication and wit and socialization, actually. So he was very, very famous because of his work, and his work is obviously extremely path-breaking, but also he was famous because of his presentation and his ability to kind of give talks and explain his science. So in that way, very different from Newton. But I really appreciate that Newton, being so introverted, still found a way to get his work out there and was so dedicated to that whole topic, which must not have been easy on somebody who is so introverted to then also contribute to the field at large. He could have just kept it all to himself, but he didn't. And he wrote those books. And the books This is why books are so great. Even the introverted people can communicate through books and writing. You don't have to be out there on stage giving a talk. um, so yeah. Hello Raikudo. Hello Nathan. Hello Poyo. Hello Nathan again. Hello Doro. Good answer to my question. I agree. Newton, I mean, it's easy to like Newton. Very easy to dedicate one's. It's easy to like Newton in history. That is, as a historical figure, he's very, very, very important. So it's very easy to appreciate historically everything that he did. Again, because of documentation. If he had not documented his work, then we would not know very much about what he did. So this is what I want to stress: is that even if you're an introverted person, but you work on things, you might want to document very well. And look to Isaac Newton for that, because if he did not, then that would have not gone very well for him and his physics career and his optics career and his math career, right? He's a physicist as well as a mathematician with his work for calculus. And again, he invented calculus because he was motivated to be able to mathematically formalize the physics that he was working on. So again, brilliant, just a brilliant guy. And he was very young, I believe, when he did a lot of this. So very dedicated young man indeed. Raikuda says, very easy to dedicate oneself to discovery when there's barely any distractions. There's always distractions, I would say, at any given time for anybody. He could have been distracted with his doggy. I think his dog was named Diamond. He could have been distracted with socializing. There's always an option to go out and do things other than stay home and, just work on your interests. I'm not saying I totally agree with only staying home and not going outside. I mean, hopefully he took walks. Otherwise, his mental health would have been kind of suffering. But pretty much, but at the same time, I think being a recluse is also good, because back in the day, it kind of saved you from infectious diseases like the plague and whatnot. So I do believe that there was something like that with Newton as well, where he very cleverly avoided being sick because of being such a recluse. So for a recluse, I think amazing work. It really just makes sense. Like, he did a lot of work and he was an introvert, and so then he wrote about it and that was it, and he kept working more and more every day. Amazing. Love it. I always liked Aristotle's work. Einstein had a clown persona. Einstein had a good way of communicating effectively. He had, I think, a type of emotional intelligence which led him to be a good orator, a good communicator. I think he had relationships. Like, he was a more wholesome person in that sense. He had his first wife, his second wife, he had children. I mean, I don't know how exactly he was as a father. He had, colleagues. He was more part of the sort of bigger life than Newton was. Newton, while working by himself, discovers the laws of motion, laws of gravity. He's then asked why planets orbit in ellipses, so he invents calculus to answer that. He then turns 27. Exactly. So Newton is really quite something else. Like, he was extremely prolific, contributing a lot. But then, I mean, Einstein was very prolific too. He gave us those four major things in 1905, and then he did general relativity, and he had already won the Nobel Prize by then. But his dedication, I would say Einstein's dedication to finishing up relativity and coming up with the general theory of relativity after the special theory of relativity was done already, and then dedicating the rest of his life to come up with the grand unification theory, even though that wasn't complete in his lifetime and still is sort of a question mark at this point. That is also a big dedication. And I would say I'm kind of sad that Einstein did not fulfill his grand unification dreams. And those are still really difficult even now. We've been talking a little bit about string theory, and that string theory is sort of a candidate for that. But at the same time, because it has so many dimensions, you can't really test it out and prove it out and experiment. And so that makes it difficult to make it a really, really legitimate thing. But Einstein was working hard and dedicated towards that cause. So I would say, I mean, they were both very dedicated, just very different people. He's honestly the most influential person in scientific history. I think he is the most influential. I think Einstein is the most influential, especially for popularizing the topics. So because Einstein was a good communicator orally, like he gave good talks, so he became more of the image of a scientist, a mad scientist, that type of thing. He became more of the image for that. Even now, if you like, he became very famous. So I would say Einstein and how he was as a person is more famous. But as far as the influence on physics and mathematics, I would say, yeah, Newton is the most influential. Without a doubt, I don't think that there's a rival of Newton. Just like there's not a rival of, Galileo for what Galileo did. There's really nobody like Galileo. There's really nobody like Newton. There's really nobody like Einstein. There's really nobody like Marie Curie. Like these are all big scientists in their own ways, very unique ways. The discoverer of radioactive elements and radioactivity. I mean, it had a special significance in history and in the world that nobody else can really match at that point, right? Fact about Einstein: on his deathbed, I don't know. Tesla. Oh, Tesla is another really good guy. I love Tesla. He's actually a very, very awesome guy. Yeah, Nikola Tesla. So him. I also really like Faraday and his experiments in the lab showing electromagnetism. These also, you have to remember that Einstein was standing on the shoulders of giants. By the time Einstein is coming, he already had Faraday and Maxwell and Newton and everybody before him. So and Newton, of course, had Galileo before him, and Copernicus, and all Aristotle, all that stuff. So everybody is standing on the shoulders of giants. But that's another thing to note as well, that in physics, in experiments, in science, it's very important to stand on the shoulders of giants and really see what has been accomplished so far and get the deeper insight from it. Like really study it so well, where you can then advance the topic, where you become such an expert on the topic and learning it, that then you can advance it, and maybe you can even find flaws in it and you can correct it. For example, Newton worked on the classical theory for gravitation, and then Einstein worked on the relativity or relativistic theory of gravitation, and the general theory of relativity is the more correct, more updated theory for gravitation. So again, understanding what exactly Newton did and understanding exactly where the science was and then bringing it to the next level is what some of these people are doing. The ancient Egyptians are heavily underrated in science. They figured out many medical procedures as well as physics, which they used to move the 5-ton stones for pyramids. Very underrated, I'm sure. The problem with the ancient Egyptians and a lot of the ancient other cultures too, like I'm from India, it has an ancient history, ancient India, ancient Egypt, Mesopotamia, all these ancient times. The difficulty is that this was so long ago that it's difficult to kind of know exactly what was done when and by whom. Again, documentation is probably the biggest challenge there. Some things were documented, but some things were not. And so in science, really a big part of doing science and doing experiments and doing physics and math or anything researchy is to do it, but then also to document it. If you don't document it, if you don't give good talks on it and explain to people what you've done, if you don't write it down and publish papers, this is why in academia we say publish or perish, because if you don't publish, if you don't have the documentation like these ancient Egyptians, and not only documentation, I mean, there could be documentation that I just don't know about. So it's really a limitation of the documentation, distribution, and to some extent education. So if I don't know enough about the ancient Egyptians, it could be that I'm just not educated in ancient Egypt. And so it's a limitation of education, as well as a limitation of documentation. So those things, that's why science education, documentation, publishing, those are all so very important. Otherwise it didn't happen, you know, except for those giants. I thought aliens built the pyramids. So anyway, thank you for that question. That led us to kind of discussing a number of scientists, but they're still trying to figure it all out. I'm still waiting on Stonehenge. Oh my gosh, I've been to the Stonehenge, not super close, but yes, Ayurveda, yeah, Vedic medicine and things like that. Yep. The ancient Indian civilization was also very influential with medicine. I believe they also played a role in some, yes, a lot of mathematical principles, a lot of the medical medicine, Ayurveda, Vedic, you know, sort of cures for different things, medicinally, are things that are from ancient India for sure. So ancient India, you know, all these ancient civilizations gave us a lot of things that maybe some of it is lost at this point because of the transmission of information and yes, mental health and meditation. There you go. Lots of that. No touching the blue rock. I don't know what that means, but okay. Hello again to everybody. Raikudo, Wade, Boyo, Doro, Nathan, everybody, thank you so much for being here and getting this discussion going. Thank you for all the good questions and comments. Really appreciate everybody for being here, and welcome to the live. And we will get started with the arrow of time. And if you have more comments, then feel free to write them. I'm enjoying reading them and talking about it. But yeah, so that's sort of what we do here. We discuss, we, you know, read your comments. If there is comments, especially about the topics or related, then we spend some time on it. Sometimes we spend the whole live discussing one question that somebody in the audience asked. So that can happen too. We are talking today about the arrow of time. Is this the beginning of the book? No. So we are talking about time, specifically the arrow of time. Yes! So we are actually towards the end of the book, A Brief History of Time by Stephen Hawking. And the chapter we're on is called The Arrow of Time. The pillars of Stonehenge are blue rock, and I guess the public can't touch them. Oh, I see. So basically, this topic that we're on, we just have a couple more topics after this in this book, including wormholes and time travel. So hello Diego, hello Raikudo, hello Poyo. So we started another book, you're right. And can we get 10 likes? We started another book, but we are kind of finishing up Brief History of Time, and then we'll move on to other books. So we kind of did start another book, but we're kind of finishing up this book for now, and there's just a little bit left. Arrow of Time is the one we're on at this time, the topic right now. But after this, there's only a couple more topics, and then we'll be done with this particular book, and I have to return it to the library. So that's why we're discussing that right now. So we mentioned briefly right now that arrow of time, meaning which time is like, which way is time going forwards, basically. Sometimes, you know, we get stuck on something in life and you might think, oh my gosh, time, you know, I'm really stuck. But pretty much time is flowing, and, you know, we should be kind of going forward in time. And the way we human beings kind of perceive time psychologically, that's called a sort of a psychological time, is that we understand and we can remember the past, but we don't remember the future, for example, right? But both are sort of, you know, the ways in which time has flown. if you just go this way, then it's the past. If you go that way, it's the future. But the way we perceive the arrow of time is that we think of this way as the arrow of time because this is the way in which the future is going, and we only remember that way. We don't know this way yet. So that's one way of thinking about the arrow of time. The other way is entropy, where the second law of thermodynamics says that things get more and more disorderly over time. As time increases, as the arrow of time is going in the forwards direction, you will have more and more entropy in the universe. The entropy always increases. So if you're sort of confused about which way is the right way in time, then just look at the entropy changing, and if it is increasing, that's your arrow of time. And then lastly, there is the cosmology way of thinking about time, which is the expansion of the universe. We know that the universe is expanding, and so if the arrow of time says that the universe is expanding, then that's the right direction. If it says, oh my gosh, the universe is contracting, then you're going backwards in time. So hopefully that's not happening to you and whatnot, because then we will lose you. But here we go. Let's get started with what Stephen Hawking is saying here, because he's actually going to bring us through this topic and make some arguments about how to understand and sort of resolve these three different types of ways of understanding the arrow of time. Okay, so here we go. Let me get a little settled here. So in this chapter, Stephen Hawking shall argue, that the no boundary condition for the universe, together with the weak anthropic principle. So the no boundary condition meaning that there is no beginning or end to the universe at this point. It's flat, infinite, and it's not like we can trace back to where, there is some edge of the universe or something. There's no such edge that we know of as far as the no boundary condition. Can explain why all three arrows point in the same direction. So these arrows of time, according to Stephen Hawking, might just be pointing in the same direction. And why is that? And moreover, why a well-defined arrow of time should exist at all. I shall argue that the psychological arrow is determined by the thermodynamic arrow. So this psychological arrow, meaning we think that time is going forwards when we remember the past and not the future. And also the cup of tea that I was talking about, if it spills and it breaks into a lot of pieces and it's on the floor, well, that's the arrow of time. Where it was more orderly is the past, and where it becomes more disorderly is the time moving in the forward direction. So entropy might be another way of saying that as well. It is a way of saying that. If one assumes the no boundary condition for the universe, we shall see that there must be well-defined thermodynamic and cosmological arrows of time, but they will not point in the same direction for the whole history of the universe. However, I shall argue that it is only when they do point in the same direction that conditions are suitable for the development of intelligent beings who can ask, why does disorder increase in the same direction of time as that in which the universe expands? So this thing about the arrow of time, where the universe expands, also being the arrow of time entropy wise, I was going to say entropically or entropy wise, thermodynamically, really thermodynamics is the second law of thermodynamics, is that law. Why those are sort of the same is what he's going to talk about. I shall discuss first the thermodynamic arrow of time. The second law of thermodynamics results from the fact that there are always many more disordered states than there are ordered ones. So this is one thing about the second law of thermodynamics, is that there are always more ways to be disorderly than there are ways to be orderly, right? Like say, if I want to be very organized, then there's probably some ways of being organized. But if I want to be disorganized, there are many, 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 many ways and options to be disorganized. Sometimes that can be an issue, actually, but here we go. For example, consider the pieces of a jigsaw in a box. There is one and only one arrangement in which the pieces make a complete picture. On the other hand, there are a very large number of arrangements in which the pieces are disordered and don't make a picture. Suppose a system starts out in one of the small number of ordered states. As time goes by, the system will evolve according to the laws of science and its state will change. At a later time, it is more probable that the system will be in a disordered state than in an ordered one because there are more disordered states. Thus, disorder will tend to increase with time if the system obeys an initial condition of high order. Wow. Disorder will tend to increase with time if the system obeys an initial condition of high order, because the initial condition of high order is sort of this minority state, whereas many options are there to be disordered. Suppose the pieces of the jigsaw start off in a box in the ordered arrangement in which they form a picture. If you shake the box, the pieces will take up another arrangement. So just by, it's like a brand new car. What is? If you shake up the box with the puzzle, there's just so many ways in which it can fall, and the puzzle will be all messed up and all the pieces will be all disorderly. And the way in which that can happen, the various states that the disorderly puzzle pieces can be in is just so very many. If you shake the box, the pieces will take up another arrangement. This will probably be a disordered arrangement in which the pieces don't form a proper picture, simply because there are so many more disordered arrangements. Some groups of pieces may still form parts of the picture, but the more you shake the box, the more likely it is that these groups will get broken up and the pieces will be in a completely jumbled state in which they don't form any sort of picture. Thank you so much for being in the live. Can you please like the live? Can we get 10 likes? So the disorder of the pieces will probably increase with time if the pieces obey the initial condition that they start off in a condition of high order. And whatever way in which time has to flow for the thing to be in a more disordered state is probably the right or the forward direction of time, because again, the initial condition of being in high order is just one state, whereas there's so many states for it to become to go into once you shake the box. Suppose, however, that God decided that the universe should finish up in a state of high order. So what about God? So sometimes in this book, God comes up, even though typically spirituality is not really something that we feel obligated to address in physics, but in cosmology, because it is so the universe is, after all, the entire universe, and so it sometimes comes up. Suppose, however, that God decided that the universe should finish up in a state of high order, but that it didn't matter what state it started in. At early times, the universe would probably be in a disordered state. So if there's a God and God decides that the universe should end up in a high orderly state, then it could be that in the beginning it was in a more disorderly state, and now it's going to go towards the high order. So this would mean that disorder would decrease with time. If God wanted that, that is, you would see broken cups. You would see broken cups gathering themselves together and jumping back onto the table. So the thing that we just talked about, hello, Professor Nick, last line of defense when answers are lacking. Exactly. It is nice to have faith in something. It can help on the harder days, especially. But if we're saying that God would want more order and less disorder as the universe does something, I guess. I don't want to say expands, because actually expansion leads to disorderliness. But as the arrow of time, I guess, goes in the right direction, in other words, well, you would see those broken cups you would see those broken cups gathering themselves together and jumping back onto the table instead of going from a highly ordered state to a disorderly state and being the spilled cup with the broken pieces and the tea and everything all on the floor. However, any human beings who were observing the cups would be living in a universe in which disorder decreased with time. Disorder decreased with time. So it's almost like if we were used to such a universe where the disorderliness decreases over time, then if we saw the cups putting themselves back together on the table and going from broken to unbroken, that might be, normal at that point. Thank you so much. Did you like the live, Professor and John Jones? John Jones and everybody, thank you so much for being here. And could you please like the live? And can we get 10 likes? So, they would remember events in the future. If this was the case, then those types of people who lived in that type of universe might just remember the future. Right? So I shall argue that such beings would have a psychological arrow of time that was backward. That is, they would remember events in the future and not remember events in the past. When the cup was broken, they would remember it being on the table, but when it was on the table, they would not remember it being on the floor, because they would know the future and not the past. Ah, I see. It is rather difficult to talk about human memory because we don't know how the brain works in details. That's a good question. I'll come to you. So, like the live. Thank you. So the question about the Big Bang, we will definitely talk about it, but I'm not sure that the Big Bang was more disorderly than the current universe. The entropy has been increasing in our universe constantly, and in the future it will keep on increasing. So, and whether the universe will end up orderly, probably not. And also, currently the universe is expanding and there's no signs of a contraction. We don't expect it to be contracting again in a big crunch. So it should be getting more and more disorderly. Okay? Okay. So it is rather difficult to talk about human memory. It's rather difficult to talk about human memory because we don't know how the brain really works, according to Stephen Hawking. We do, however, know all about how computer memories work. I shall therefore discuss the psychological arrow of time for computers. Maybe he likes computers more than people. I think it is reasonable to assume that the arrow for computers is the same as that for humans. If it were not, one could make a killing on the stock exchange by having a computer that would remember tomorrow's prices. That is actually quite relevant right now, isn't it? A computer memory is basically a device containing elements that can exist in either of two states, the binary, right? A simple example is an abacus. In its simplest form, this consists of a number of wires. On each wire, there are a number of beads that can be put in one of two positions. Before an item is recorded in a computer's memory, the memory is in a disordered state with equal probabilities for the two possible states. The abacus beads are scattered randomly on the wires of the abacus. After the memory interacts with the system to be remembered, it will definitely be in one state or the other according to the state of the system. Each abacus bead will be at either the left or the right of the abacus wire. So the memory has passed from a disordered state to an ordered one, in this case. However, in order to make sure that the memory is in the right state, it is necessary to use a certain amount of energy to move the bead or to power the computer, for example. So there's energy involved in doing this with the computer. This energy is dissipated as heat and increases the amount of disorder in the universe. So see how it's very difficult to contain the universe in a very orderly state. Even this energy that goes into the computer to do this whole thing that we just talked about actually makes heat, and that dissipates into the universe and increases the amount of disorder in the universe. One can show that this increase in disorder is always greater than the increase in the order of the memory itself. Thus, the heat expelled by the computer's cooling fan means that when a computer records an item in memory, so when you are doing a job which requires putting things into an orderly state, or basically putting thing into your memory, whether that's the human brain's memory or a computer memory, the total amount of disorder in the universe still goes up. Still goes up. The direction of time in which a computer remembers the past is in the same as that in which disorder increases. As disorder is increasing, so is that computer putting things into memory. So is us putting things into our memory. That's why we remember the past and not the future. Our subjective sense of the direction of time, so it's a bit subjective. I mean, some people, there are divination and spiritual practices where people can sort of predict the future. So maybe they are kind of remembering the future in that case. But subjectively, mostly, we remember the past and not the future, okay? Our subjective sense of the direction of time, the psychological arrow of time, is therefore determined within our brain by the thermodynamics arrow of time. So this whole disorderliness increasing and our psychological understanding of time are the same. Just like a computer, we must remember things in the order in which entropy increases. This makes the second law of thermodynamics almost trivial. It's the only law that is kind of sort of taken for granted, but it's very beautiful. It's very elegant. It can answer a lot of questions, basically. Interesting. So this makes the second law of thermodynamics almost trivial. Disorder increases with time because we measure time in the direction in which disorder increases. You can't have a safer bet than that. But why should the thermodynamic arrow of time exist at all? That's our next question. Or in other words, why should the universe be in a state of high order at one end of time, the end that we call the past? Why indeed? Why is it not in a state of complete disorder at all times? After all, this might seem more probable. And why is the direction of time in which disorder increases the same as that in which the universe expands? So that's where it gets very interesting, because why have this disorderliness increase with the arrow of time, and why also does the universe expand? So we know that the universe has been expanding. So that's just a measurement. That's a cosmological fact. But it's been expanding with the arrow of time. It's been expanding, in the past it was less expanded, and now it's more expanded. So it's almost like if you didn't have a watch, but you had a very good sense of the universe's expansion, that too would give you a sense of time, a sense of the arrow of time, right? So it's interesting to think of it that way. In the classical theory of general relativity, one cannot predict how the universe would have begun, because all the known laws of science would have broken down at the Big Bang singularity. So remember how in general relativity, the fact that the Big Bang is a singularity, the beginning of the universe is where everything kind of breaks down. meaning all the equations, all of the things we understand don't really work at the Big Bang. So we call it a singularity. Things break down at that point. But that's because it's really after the Big Bang that that is what we're explaining with all of physics, with general relativity. I mean, we actually briefly looked at how quantum mechanics would do it a little different, but in general theory of relativity, for example, things kind of break down at that singularity, at the Big Bang. And so it's almost like saying, let's forget this part, and then time actually starts, and things start to be able to put into equations and whatnot. So, and that's why he said in the classical theory of general relativity. So in quantum, we looked at it a little bit differently. Remember, we had this thing called imaginary time and whatnot. So we looked at a little bit differently with quantum mechanics. But in the classical theory of general relativity, which is what Einstein worked on, it's actually kind of sad / concerning that the Big Bang itself, being a singularity, means that the things don't make sense at that particular mathematical point in this universe. Okay, so in the classical theory of general relativity, one cannot predict how the universe would have begun because all the known laws of science would have broken down at the Big Bang singularity. And that's what a singularity really means. Thank you, John Jones. How are you doing? This would have led to a well-defined thermodynamic. So let me read that again. The universe could have started out in a very smooth and ordered state. This would have led to well-defined thermodynamic and cosmological arrows of time as we observe. But it could equally well have started out in a very lumpy and disordered state. In that case, the universe would already be in a state of complete disorder. So disorder could not increase with time. It would either stay constant, in which case there would be no well-defined thermodynamic arrow of time, or it would decrease, in which case the thermodynamic arrow of time would point in the opposite direction to the cosmological arrow. So expansion of the universe and the thermodynamic arrow of time did not have to match up. Okay, neither of these possibilities agree with what we observe, though, because what we observe is that disorderliness increases as well as the expansion of the universe is happening as time moves forward. So, however, as we have seen, classical general relativity predicts its own downfall. When the curvature of space-time becomes large, quantum gravitational effects will become important and the classical theory will cease to be a good description of the universe. One has to use a quantum theory of gravity to understand how the universe began. So that's the other thing. Remember also that Stephen Hawking is one of those few people who have combined quantum mechanics and general relativity. In fact, this whole Hawking radiation, this whole thing about black holes sometimes emitting something because of quantum effects. Generally, they don't emit things. They swallow things. They eat things. But the fact that black holes have a temperature mean that because of quantum fluctuations, black holes can sometimes emit things as well. In fact, they are emitting things. But it's this quantum fluctuation thing. You have to do quantum mechanics way of explaining it, which does not come from general relativity. So he's basically saying that you might need a quantum theory of gravity to compensate for the fact that the singularity is sort of something that is not coming from general theory of relativity. The singularity that is the beginning of our universe, or the Big Bang, is sort of not really explained well by general relativity. And, this question about the arrow of time, well, we observe that the arrows of time are matching up between second law of thermodynamics as well as the cosmological arrow of time. In a quantum theory of gravity, as we saw, and why the quantum theory of gravity comes up here again is because, unfortunately, general theory, the classical theory of general theory of relativity, the classical theory, which is the theory of gravitation by Einstein, does not quite tell us about the singularity. It does not explain that well. So if you don't explain the beginning, then arrow of time may have some difficulty basically to also explain from that perspective. So in a quantum theory of gravity, as we saw in the last chapter, in order to specify the state of the universe, one would still have to say how the possible histories of the universe would behave at the boundary of space-time in the past. So one could avoid this difficulty of having to describe what we do not and cannot know if the histories satisfy the no boundary condition. They are finite in extent but have no boundaries, edges, or singularities. In that case, the beginning of time would be a regular, smooth point of space-time, and the universe would have begun its expansion in a very smooth and ordered state. So from quantum theory of gravity, where we basically don't have to deal with the singularity because of quantum ways of doing things, the imaginary time thing we talked about in the last chapter and such, perhaps it's a very smooth regular point in space-time. And then it does actually start with a smooth and ordered state, being the Big Bang. Stephen, hello. Yes, Doro is here. Stephen, can you like the live? Thank you so much for being here. And can we please like the live? Thank you. It could not have been completely uniform because that would violate the uncertainty principle of quantum theory. There had to be small fluctuations in the density and velocities of particles. The no boundary condition, however, implied that these fluctuations were as small as they could be, consistent with the uncertainty principle. So the universe would have started off with a period of exponential or inflationary expansion in which it would have increased its size by a very large factor. So we've talked about the inflationary era, where the universe was expanding a lot. Wow! I have the first 2 pages of my book on Instagram for you to read. Oh my gosh! Well, tell us your Instagram account. During this expansion, the density fluctuations would have remained small at first. So remember how the universe, when described by the cosmic microwave background radiation, when we talk about the early universe, it's basically a smooth universe, but it has these little fluctuations, or what we call overdensities, or what we call little uncertainty and little changes or little departures from the from the point where things had to be in order to be totally homogeneous for the position and velocity and whatnot, and those eventually led to galaxies and stars and us. So during this expansion, we're talking about the expansion of the universe, the density fluctuations would have remained small at first. So those density fluctuations that we talked about earlier as well would have remained small at first, but later would have started to grow. So even the fluctuations, which may have been small at first, but would have started to grow. My username is, ooh, very nice. But do stay in the live now, and you can always go back to, you can always go check out Stephen's Instagram later on. Congratulations, Stephen, for the launch of your book on Instagram. And we look forward to seeing it grow and grow. Stephen T. Spears, is that your middle name? Is it with a T? Is it Tom? Is it Timothy? Thomas? Therius? Okay, we'll keep reading. All right, so during this expansion, the density fluctuations would have remained small at first, but later would have started to grow. Very nice, Stephen. Regions in which... I guessed it. Thomas. Wow. Regions in which the density was slightly higher than average would have had their expansion slowed down by the gravitational attraction of the extra mass. Eventually, such regions would stop expanding and collapse to form galaxies, stars, and beings like us. So remember that if you give gravitation a chance, if you keep expanding and there's no inhomogeneities, then gravitation never wins and never gets a chance to clump together matter and form galaxies and stars and us, right? But if something happens where there's a fluctuation and there's an overdensity and the fluctuation also increases, eventually such regions would stop expanding and collapse to form galaxies, stars, and beings like us because of gravitation, because gravitation has the chance now to do that, right? It's sort of that the expansion of the universe is sort of an anti-gravity effect, right? It's not allowing things to clump. But if you have those overdensities, if you have those fluctuations that led to the overdensities, then you're actually giving gravitation a chance now. And that's why we're all here. We're all here. If gravity never won, then we would not be here, okay? The universe would have started in a smooth and ordered state and would become lumpy and disordered as time went on. This would explain the existence of the thermodynamic arrow of time. But what would happen if and when the universe stopped expanding and began to contract? If it did that, would the thermodynamic arrow reverse and disorder begin to decrease with time? So I think somebody asked about this. They were asking about the Big Bang and if we're more orderly or disorderly. And if we were to go back to sort of a big crunch, if we were to contract instead of expand in the universe, if the universe stopped expanding because of its expansion rate being something different than what it actually is and led to a contraction back to sort of a big crunch, then what would happen? Would the thermodynamic arrow reverse and disorder begin to decrease with time? This would lead to all sorts of science fiction-like possibilities for people who survive from the expanding to the contracting phase. Would they see broken cups gathering themselves together off the floor and jumping back onto the table? Would they be able to remember tomorrow's prices and make a fortune on the stock market? It might seem a bit academic to worry about what will happen when the universe collapses again, as it will not start to contract for at least another 10,000 million years or 10 billion years. But there is a quicker way to find out what will happen. Jump into a black hole. The collapse of a star to form a black hole is rather like the later stages of the collapse of the whole universe. So the collapse of a star. We actually talked about this, how gravitation really wants to compress things. So much so that even though at first gravitation allows a star to form, but later on gravitation is what kills a star and it becomes a dead star or a cold star, which is something like a white dwarf or a neutron star or a black hole. The ultimate compression is a black hole. The collapse of a star to form a black hole is rather like the later stages of the collapse of the whole universe. So if disorder were to decrease in the contracting phase of the universe, one might also expect it to decrease inside a black hole. So perhaps an astronaut who fell into a black hole would be able to make money at roulette by remembering where the ball went before he placed his bet. So if the astronaut were to survive being in the black hole, maybe they can see the future. Maybe. Classically, time actually stops in a black hole, but let's see what he has to say about this. Unfortunately, he would not have long to play before he was turned to spaghetti, nor would he be able to let us know about the reversal of the thermodynamic arrow or even bank his winnings, because he would be trapped behind the event horizon of the black hole. So that's all to say that you can't really come out of the black hole, and information cannot come out of a black hole. So even if the astronaut were to fall in and figure out being able to see the future, you can't really tell us anything about it because you're trapped inside the event horizon of the black hole. At first, I believed that disorder would decrease. At first, I believed that disorder would decrease when the universe recollapsed. So, Stephen Hawking thought for a hot second that maybe when the universe recollapses, goes into a contracting phase, maybe disorder would decrease. Maybe. What do you think? Space spaghetti with gravity stirring the pot. Yes, exactly. Space spaghetti is right. That's a good way to put it. Going past the event horizon of a black hole will turn you into spaghetti. Steven says he likes spaghetti no matter what it is. Okay, so let's see. At first, I believed that disorder would decrease when the universe recollapsed. This was because I thought that the universe had to return to a smooth and ordered state when it became small again. So this is sort of the thinking, is that maybe we came from a smooth and ordered state. So if we recollapse, maybe we have to become smooth and ordered again. But is that so? This would mean that the contracting phase would be like the time reverse of the expanding phase. People in the contracting phase would live their lives backward. They would die before they were born and get younger as the universe contracted. Reese! I have to take a water break. Reese is here. Goodness. Where have you been? Where have you been, Reese? Everybody has missed you and wondered where the frick you are. Hello, Wonder Boy. Doro. Doro. I thought you had just not been live. What do you mean? I go live every day almost. We've still been doing the lives, man. Why have you not? Can you not see the lives? Did you block my lives? How come you have not seen my lives? How is everything? Everything good? Otherwise? Okay, so at first I believed that disorder would decrease when the universe recollapsed. This was because I thought that the universe had to return to a smooth and ordered state when it became small again. This would mean that the contracting phase would be like the time reverse of the expanding phase. People in the contracting phase would live their lives backwards. They would die before they were born and get younger as the universe contracted. This idea is attractive because it would mean a nice symmetry between the expanding and contracting phases. However, one cannot adopt it on its own, independent of other ideas about the universe. The question is it implied by the no boundary condition, or is it inconsistent with that condition? As I said, I thought, so Stephen Hawking thought at first that the no boundary condition did indeed imply that disorder would decrease in the contracting phase. I was misled partly by the analogy with the surface of the Earth. Yay, everybody is happy to meet each other. I was misled partly by the analogy with the surface of the Earth. If one took the beginning of the universe to correspond to the North Pole, then the end of the universe should be similar to the beginning, just as the South Pole is similar to the North. So remember, there was this confusing part of the book where he talked about North Pole and South Pole of the universe. So whatever. It's sort of like the Big Bang and Big Crunch and whatnot. However, the North Pole and South Pole poles correspond to the beginning and the end of the universe in imaginary time. So it's really in imaginary time, sort of a quantum way of looking at things, where you have this North Pole, South Pole of the universe being the beginning and end of time. And I can show you the picture again. We looked at it a while ago. The beginning and end in real time can be very different from each other. Yes, it's an exciting time for Stephen. Thank you. We missed you. We were wondering what happened. We were hoping that everything is good in the hood. Missed your face, yeah. Well, I've been here. I mean, I think the last couple weekends have been a little bit different. So I didn't go live on the weekends, but I'm pretty much here on the weekdays. Probably this coming weekend too. I think I'll be doing lives this coming weekend. So doing another big push. So I'm pretty much going to be live every day. I think it's because some of my lives started a bit late / early for you. So maybe that's why you didn't see it. But I've been tagging people. I've been trying to notify people of the lives. So I don't know. The beginning and end in real time can be very different from each other. So there's imaginary time and then there's real time. And so this is the real time that he's talking about now. I was also misled by work I had done on a simple model of the universe in which the collapsing phase looked like the time reverse of the expanding phase. However, a colleague of mine, so I think this is Stephen Hawking's confusions that we are talking about, and his sort of maybe some roadblocks that he had in this particular understanding of the arrow of time. So a colleague of mine, Don Page of Penn State University, pointed out that the no boundary condition did not require the contracting phase necessarily to be the time reverse of the expanding phase. Further, one of my students, Raymond Laflamme, found that in a slightly more complicated model, the collapse of the universe was very different from expansion. So this the thought that the expansion and the contraction are sort of the opposites of each other, that's not really the case, turns out. It's quite a bit more complicated than that, is what he's realizing. Yay! I realized that I had made a mistake. Stephen Hawking made a mistake. The no boundary condition implied that disorder would, in fact, continue to increase during the contraction. So that's what I kind of was thinking, that even if we had a recollapse, even if the universe started to contract again at some point because the expansion rate changes, or the rate is such where you would go back to sort of contracting again because blah, 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 because of obviously, I mean, gravitation will want things to contract, but the expansion will want things to expand. But the expansion rate is what's important in understanding whether we will keep on expanding or are we going to recollapse at some point. So even if we were to recollapse, actually, the disorderliness would actually increase. Okay, so I realized that I had made a mistake. The no boundary condition implied that disorder would in fact continue to increase during the contraction. The thermodynamic and psychological errors of time would not reverse. So the thermodynamic and psychological errors of time would not reverse when the universe begins to recontract or inside black holes. So this is the implication where even if you did a recollapse, first of all, the recollapse phase would not look like just the opposite of an expansion phase, and it would mean that entropy is still increasing. Thank you, everybody. Thank you so much for being here. What should you do when you find you have made a mistake like that? Is what Stephen Hawking is now wondering. Hi, Courtney. Don't time him out. He didn't say anything bad. He's just giving his opinion. Yeah, we're excited about Stephen's book, but Poyo wasn't saying anything rude or terrible, so don't time him out of spite. How about that? Yes. Good. Thank you. Thank you, thank you, thank you. Because I think Poyo likes the topic, so we want people. He said, shut up. Shut up is really mild compared to some of the things we've seen on this channel. And I think he or she is interested in the topic. So, Poyo, where are you? Come back. Courtney says, I didn't. Hello, Courtney. Steven says, I didn't take it any other way. Steven, congrats! Steven deserves many a congratulation. I was just letting Doro about my user. Of course, and me too. We talked about Stephen's book yesterday. So some people don't have the context. We talked about Stephen's book yesterday, and we urged him to publish it on Instagram. But at the same time, I want Poyo to be able to listen to the cosmology discussion that we're doing without getting banned. Hi, Poyo. Welcome back. Can you like the live? Thank you so much for being here. Sometimes there is some drama in the chat. I was permanently timed out. Oh gosh. Well, Poyo, I'm glad you're back, and hopefully you continue to enjoy the topic, and then there's not a ton of drama going forwards in the arrow of time. I can't join again. You should be able to. I think Reese changed the timeout to like 60 seconds, so you should be able to. Okay. I realized that I had made a mistake. The no boundary condition implied that disorder would in fact continue to increase during the contraction. The thermodynamic and psychological errors of time would not reverse when the universe begins to recontract or inside black holes. What should you do when you find you have made a mistake like that? Some people never admit they are wrong. Some people never admit that they are wrong and continue to find new and often mutually inconsistent arguments to support their case, as Eddington did in opposing black hole theory. So, sometimes in physics, there are mistakes made, and people may not actually accept that they were wrong. They might continue to kind of take the opposing side of something that is being challenged and whatnot, right? So yeah. So some people never admit that they're wrong and continue to find new and often mutually inconsistent arguments to support their case. As Eddington did in opposing black hole theory. Good job, Batman's not here, he never shuts up. That's true. That's true. Others claim, so did we ever ban Batman? I mean, there's an example of somebody who probably should be banned. So yeah, sometimes it's a little iffy here, but for the most part, if people are being not completely belligerent, we don't want to ban them or time them out. I think we want to include everybody as much as possible. So others claim to have never really supported the incorrect view in the first place, or if they did, it was only to show that it was inconsistent. Oh, there's my dishwasher. Just this clown, no bats. So by the way, Poyo, if you missed something, you can always go back into the live and rewind so that you don't miss something. That's very true. We are encouraging Stephen to publish the book. That's very true. There is context of that. Yes. We sort of take pride in letting people chat whatever. That's true. As long as the chats are not... Oh my God, dishwasher, calm down. As long as the chats are not totally crazy. And in fact, even sometimes, even when the chats are crazy, yeah, Wonder Boy banned you for saying shut up. We've seen a lot worse than shut up. Oh, Stephen is our treasured audience member. So Stephen is our regular. He is always here. He attends class very well. He's a good student. And Stephen did not take any offense. That's true. So no more banning. And no more fighting. Okay, listen up. Okay, so others claim to have never really supported the incorrect view in the first place. So sometimes when people make a mistake in physics, they will not own up to it, you know. Others claim to have never really supported the incorrect view in the first place, or if they did, it was only to show that it was inconsistent. It seems to me much better and less confusing if you admit in print that you were wrong, says Stephen Hawking. A good example of this was Einstein, who called the cosmological constant, which he introduced when he was trying to make a static model of the universe, the biggest mistake of his life. To return to the arrow of time, there remains the question, why do we observe that the thermodynamic and cosmological arrows point in the same direction? Or in other words, why does disorder increase in the same direction of time as that in which the universe expands? If one believes that the universe will expand and then contract again, as the no boundary proposal seems to imply, this becomes a question of why we should be in the expanding phase rather than the contracting phase. Baji. Oh. Baji's being very cute. One can answer this on the basis of the weak anthropic principle, conditions in the contracting phase. So, can we see the kitties? Yes, 1 second. So, Baji's coming to help out with the fights. Oh, Baji's here. Baji. Come, Baji. Mama's going to আসবে. Mama's going to আসবে. Ah. Oh. Here is Baji. Baji. You baby, to me. Tomato baby. Tomato baby. Baji, are you kidding me? Look at what he's doing. Baji. I think he's upset. Are you upset with me? Okay. Oh. Okay. Sometimes Baji wants to sit on my lap during the readings. Oh, thank you. Baji is tired today, yeah. Baji is very young. He's just a little baby. Most wholesome channel on the YouTube live. Just really chill. Thank you. Okay, so to return to the arrow of time, there remains the question, why do we observe the cosmological and thermodynamic arrows of time to be the same? Why indeed? Thank you for liking the live. Can we get 20 likes? Or in other words, why does disorder increase in the same direction of time as that in which the universe expands? If one believes that the universe will expand and then contract again, as the no boundary proposal seems to imply, this becomes a question of why we should be in the expanding phase rather than the contracting phase. One can answer this on the basis of the weak anthropic principles. We talked about the anthropic principle in a different chapter. Conditions in the contracting phase would not be suitable for the existence of intelligent beings who could ask the question, why is disorder increasing in the same direction of time as that in which the universe is expanding? The inflation in the early stages of the universe, which the no boundary proposal predicts, means that the universe must be expanding at a very close to the critical rate at which it would just avoid recollapse, and so will not recollapse for a very long time. So there are different rates at which the universe could be expanding. The universe could be expanding at a rate which makes it so that it will recollapse, relatively soon after it began in the first place. It could expand at a rate which makes it never recollapse. It just keeps on expanding even more faster and faster than it truly is. Or it could expand sort of at a critical rate which sort of just avoids a recollapse, just avoids, okay? And that's sort of close to the expansion of the universe that we do observe. So it's very interesting, but Stephen Hawking thinks that we live in the type of universe that where that is pretty much true. So the inflation in the early stages of the universe, which the no boundary proposal predicts, means that the universe must be expanding at very close to the critical rate at which it would just avoid recollapse, and so will not recollapse for a very long time. By then, all the stars will have burnt out, and the protons and neutrons in them will probably have decayed into light particles and radiation. The universe would be in a state of almost complete disorder. Aww. There would be no strong thermodynamic arrow of time. Disorder could not increase much because the universe would be in a state of almost complete disorder already. So it's almost like we live in a universe where we can sort of see this disorder happening, increasing, but there could be a point at which there's just so much disorder. It's almost like how much more disorder, right? There would be no strong thermodynamic arrow of time. Disorder could not increase much because the universe would be in a state of almost complete disorder already. However, a strong thermodynamic arrow is necessary for intelligent life to operate. In order to survive, human beings have to consume food, which is an ordered form of energy. Because again, food is a very ordered form of energy. We could just be, I guess, like photons zipping around everywhere, and we are ordered forms actually as well, highly ordered states of being right here. So in order to survive, human beings have to consume food, which is a disordered form of energy. Thus, intelligent life could not exist in the contracting phase of the universe. This is the explanation of why we observe that the thermodynamic and cosmological arrows of time point in the same direction it is not that the expansion of the universe causes disorder to increase. Rather, it is that the no boundary condition causes disorder to increase and the conditions to be suitable for intelligent life only in the expanding phase. So again, it is that the no boundary condition causes disorder to increase and the conditions are suitable for intelligent life only in the expanding phase. To summarize, the laws of science do not distinguish between the forward and backward directions of time. So the fact that we have an arrow of time is because of all these different reasons that we just talked about. There are at least 3 arrows of time that do distinguish the past from the future. They are the thermodynamic arrow, the direction of time in which disorder increases, the psychological arrow, the direction of time in which we remember the past but not the future, and the cosmological arrow, the direction of time in which the universe expands rather than contracts. I have shown that the psychological arrow is essentially the same as the thermodynamic arrow, so that the two would always point in the same direction. The no boundary proposal for the universe predicts the existence of a well-defined thermodynamic arrow of time because the universe must start off in a smooth and ordered state. So I think somebody was asking about the Big Bang. It was smooth and ordered, more so than what we are now. We are now at a more disorderly state. Hello. Hello, DHDB, DHDJ. How are you doing? We're talking about cosmology today. Physics, cosmology, astrophysics, astronomy, and cats is what this is. His name is Poyo. Well, Wonderboy, don't be rude to my other audience members just because you're a mod. You know what I mean? We want people to feel welcome here, even if they're new. Cats and the Cosmos, welcome. See, Steven is welcoming. You should be too, Wonderboy 15. Poyo Pogo. Be more welcoming and friendly, even if you're a Brit. Goodness. What is wrong with you? Okay, we'll keep going. His name is Pollo, which I think is Poyo. You know, like Pollo chicken, chicken Pollo. I think that's what it is. But you're being so rude to the new people. Hello, HXJ, whatever. Thank you so much for being here. Okay. We will talk about the arrow of time. Enough is enough. Class, become orderly. How dare you? Who is this? Oh, goodness. Disorder in the court. There is disorder. Order. Judgment. Reminds me of my old Apollo. Aw, Pollo. Polo. Polo, Apollo, but then in Spanish it's Pollo. Get it, Reese? I know you're not very cultured. I'm just pulling your leg. We go way back. We're in court. Can I be the jester? God. I'm dealing with a bunch of difficult people. Dealing with some difficult people here. Gosh. Everybody, sit down. Finger on your lips. Ever since, okay, whatever. I have shown that the psychological arrow is essentially the same as the thermodynamic arrow, so that the two would always point in the same direction. The no boundary proposal for the universe predicts the existence of a well-defined thermodynamic arrow of time because the universe must start off in a smooth and ordered state. And the reason we observe this thermodynamic arrow to agree with the cosmological arrow is that intelligent beings can exist only in the expanding phase. The contracting phase will be unsuitable because it has no strong thermodynamic arrow of time, and we need that entropy change to be a thing. We need the cup to be spilling and becoming 1,000 pieces on the floor in order for us to be suitable and in order for us to suitably exist. We exist is why we exist because of the second law of thermodynamics. The progress of the human race in understanding the universe has established a small corner of order in an increasingly disordered universe. If you remember every word in this book, your memory will have recorded about 2 million pieces of information. The order in your brain will have increased by about 2 million units. However, while you have been reading the book, you will have converted at least 1,000 calories of ordered energy in the form of food into disordered energy in the form of heat that you lose to the air around you by convection and sweat. This will increase the disorder of the universe by about 20 million units, or about 10 million times the increase in order in your brain. And that's if you remember everything in this book. In the next chapter, but one, I will try to increase the order in our neck of the woods a little further by explaining how people are trying to fit together the partial theories I've described to form a complete unified theory that would cover everything in the universe. So the next chapter is called Wormholes and Time Travel. We will do this as well. Puyo, can you watch the live from all your 200 accounts and then keep all the videos running constantly and watch all my old videos as well and watch all of the live stream episodes from the past under the live tab of my channel and just keep them constantly playing in the background? Could you do that for me, please? That will also increase the entropy of the universe. You should get more devices then, Puyo. You're letting me down. I do share some of my knowledge of astronomy if it fits the lecture. Aw, Steven. Steven is pretty much the best. It's taking me a minute. You will buy me 200 iPhones? Yes, you will. Can you do us the super chat, Puyo? Puyo has said that they will do 200 iPhones and the amount of that will be in the super chat. Reese, you know what I've been teaching, what I've been telling Chickpea to do? By the way, Reese, were you here when Chickpea Break became an account? I think you were. So Reese, did you know that nowadays we ask people to do super chats, and if somebody is trying to, be extra, we say Ver, yes. Oh my gosh, you remember their old name. Oh my gosh, Chickpea Break is here. We were just talking about you, Chickpea Break. Chickpea Break, can you like the live? Raikudo says, I left the playlists running all night and one of them most of the day. Thank you, Raikudo. Oh my gosh, Raikudo. Wow. Thank you so much. Thank you, Raikudo, for running my playlists and running them all night and all day. Thank you indeed. Thank you. Chickpea, Raikudo, Poyo, Wonderboy, everybody please like the live. Can we get 20 likes? Could we get 20 likes? So Chickpea Break is here. Hello, Chickpea. Listen, if you buy me 200 iPhones, I will give you a lot of watch hours. Listen, Poyo, we need you to buy us some iPhones. And by that, I mean that we need you to do some super chats. I think you've chatted for free enough, and now is your opportunity to do a super chat. How about that? As a new person, you have been well heard today. You've been challenging my mods and Steven. Now that I've finished the chapter, I will be addressing you. This was Arrow of Time that we just read from Stephen Hawking's book, A Brief History of Time. Hopefully you enjoyed that. The next chapter is called Wormholes and Time Travel, which we will also talk about. Probably not all of it tonight, but we will get started. Thank you so much, everybody, for being here. Thank you so much for arguing amongst yourselves, not listening to the lecture. And thank you for doing a super chat here very soon. And especially if you're going to talk a lot, then I suggest that some of it be in the super chat forum. That's right. So, Reese, did you know that nowadays, if somebody says anything weird or rude or extra, we ask them to do $500 in Super Chat for Baji's treats. $500 Super Chat for a ponytail. Somebody asked me to do a ponytail last night, and I was like, okay, well, $500 first into the Super Chat. Wow, Baji! And that would maybe give you a ponytail for the rest of the live, and we were almost done. If you buy me... Hi, Ver! Hello, Optim. I like the live. Thank you. Doro. Can we get 20 likes? Thank you. I'm going to pin that message. I'm a mod in another channel, so I needed my tools. Aww, you're a mod. Wow. It's Verse Steven. Hey Reese, we missed you. I can't super chat. I have controls on my phone. What does that even mean? I have controls on my phone. Oh, are you a kid? Aw, poor Pollo. Are you a kid? That's okay. That's okay, honey. Missed you guys too. If that's you, I have good news. Dora was here earlier, but I think he's left now. Right, Kudo, $20 super chat for being extra. Actually, it's Pollo. Pollo is a poor kid. I will make this brief out of respect to Pollo, but my first 2 pages of the book are on Instagram now. That's right. Steven's book is on Instagram. We were urging Steven yesterday to just post his book on Instagram instead of worrying about all kinds of things with the publishing. We just wanted to get started reading his book. So it's on Instagram, first 2 pages. Pollo says, can you be a mod? No. No. Let's raise money for Pollo. No, we need money for this chat. We need money for Baji the handsome cat. And that rhymes. Pollo, you need to be coming to these lives a lot more and becoming a regular and kind of understanding sort of the context and whatnot in order for you to be considered as a mod. And also sometimes I make an exception and make you a mod in the first instance if you just ask a lot of related questions, plural. If you ask a lot of questions that are related to physics, astronomy, astrophysics, cosmology, that's free to do. Then also sometimes I make you a mod. Like I made somebody else a mod the other day. Austin became a mod the other day. He too is a kid, and he was asking a lot of good questions, and he showed a lot of good interest and curiosity. So instead of getting into trouble with the other people on the chat, you may consider doing that. I won't ban people like Wonder Boy. I will join 5 million times to earn my status. Aww. Pollo, thank you so much and welcome to the live. For Pollo was a front. We would have just give him a small cut of the money for being useful. In what way? Oh, I see. Okay, guys. Well, we finished up Arrow of Time. We are going to start with my... On all my accounts, I will join. Then can I be a mod? We will see, Pollo. How about we see you tomorrow? And the next day, and the next day, and we will see. At some point, I may make you a mod. I will have to see how it goes. Steven says, I do not ask to be a mod. Steven should be a mod. No, because Steven, I want him to just enjoy. Being a mod is kind of like some work. Super chat to be a mod. There you go. See, Chickpea Break gets it. Chickpea Break has been helpful in spreading the message of the super chats. So for that, I very much appreciate you, Chickpea Break. $300 super chat to be a mod. You know, Pollo, you should go get your parents. if you're really that badly wanting to be a mod, but also save your money. Earn money first to save it. That would also be good. But also do a super chat to do a super chat to support the live. Thank you so much. Thank you for liking the live. Can we get 20 likes? It's up to Indri if I become a mod and I do not want the job. I know, that's why I haven't made you a mod. Steven, I just want you to sit back, relax, and enjoy the flight. Steven Spears just gets to sit back, relax, and enjoy the flight, and he says good, relevant astronomy-y type of information, and he enjoys the kitty cats. I don't want him to be getting all involved in the mod war. Why am I being made fun of for being a child? We're not making fun of you. Reese, don't make fun of him. I just choked on my biscuit. Reese, don't make fun of a kid. Don't worry, Poyo, she's a kind person, but we corrupt her sometimes. I did not make fun of anybody being a kid. Reese, this is all Reese is doing. Reese's Pieces. Ever since you started to have a kid, Reese, you've been very mean. I'm not an ordinary kid. We definitely corrupt her. I am not corrupt, okay? Hi, Baji. Baji. Come, Baji. Baji wants to be in the lap. Come, Baji. Baji wants to be in Mama's lap. Poyo says I'm smart. Aw, Poyo. I'm sure you're smart. Don't you worry. I do enjoy the flight. But I will say, Baji. Baji's like holding me too tight. Your nails are digging into me, Baji. I will say the first time I was in a plane, the plane was hit by wind shear and the plane fell like 1,000 feet. Oh gosh. Thank you for joining the live. Can we get 20 likes? Dollar bill. Would an average 12-year-old listen to a physics lecture? I took physics since I was 10. And I wanted to be a physicist by the time I was 11. So, I don't know, Poyo. You know, keep on keeping on. But also, thank you so much for being here. I really appreciate you as an audience member and for listening to the physics lecture. Thank you so much. Okay. Study astrophysics and Nova. Aw. Oh my gosh. Is that the only time you flew? And did you not fly again because it was a horrible experience? Gosh. Steven. Thank you everybody for being here. Can we get 20 likes? Wow. All right, so the next topic here today is wormholes and time travel. So we spent some time looking at the arrow of time and looking at how time moving forward, what really is the meaning of that. And we looked at the three ways, once again, to summarize what we just talked about. Arrow of time, meaning entropy way. So this is where with the forward direction of the arrow of time, entropy always increases in this universe. The psychological way in which human beings remember the past, but not the present, and that is the arrow of, or sorry, remember the past, but not the future. And so that is the arrow of time. Arrow of time is going towards the future. And the way we know that is because we remember the past and not the future. We could have remembered the future if our brains kind of worked differently, or if this universe worked differently, but that's not the case. The third thing is the arrow of time based on cosmology, which says that the expansion of the universe is happening with the arrow of time. So as time increases, the universe is expanding. So expansion of the universe is happening versus recollapse or contraction. Okay, so those are the main points, and we talked about how these all kind of match up actually, and Stephen Hawking made an argument for why these three types of meanings, or three different meanings of the arrow of time kind of match up. Okay, now we will move on to more exotic topics such as wormholes and time travel. Let's see what he has to say about that. And we have also mentioned wormholes in a previous context. Remember, we talked about it from the book Einstein's Cosmos by Michio Kaku. So if you, by the way, missed that live, then way back, we've talked about it in those types of lives as well. Last year, October, November, December-ish timeline is when I would go back and revisit those live stream episodes. You can go under the live tab on my channel and find any of these things from the past, okay? That are posted already. Thank you for being in this live once again, and thank you so much. Welcome everybody. Welcome one and welcome all, and can we get 20 likes? That would be amazing. I'm 12th grade language arts, 10th grade math. Thank you so much, Poyo, for all that information. Keep on keeping on. Look at the comments. Are you talking to me? I am looking at the comments right now. He theorized a new metal alloy, guys. Tungsten carbide, 35%, 65% titanium, used for electromagnetic plating. That was the alloy. Awesome, Poyo. Everybody, thank you so much, and I'm glad you're getting to know each other so well, including the genius ratings and the tungsten and the titanium that's happening in the comments. Love it. Let me take a sip of water, and then we'll continue with the next topic, which is wormholes and time travel. Thank you so much for being here, and can we get 20 likes? Okay. I'm glad that everybody is having so much fun in the comments. I may miss some particular comment when there's so much going on, but guess what I'll really notice is a super chat. So you should feel free to do one. when and if inclined. In fact, did I share the live, guys? Maybe I forgot to share the live. Maybe I'll do that right now. I think I'll go to bed a little early today and then try to do a special live tomorrow. So usually I take, well, depending on the kind of week I'm having, if I've also been working on the weekend, then sometimes I take Wednesday off, but I don't think I'm going to take tomorrow off. I think there's going to be a special live stream episode streaming thing tomorrow. So be ready. Get ready for tomorrow's very special live, guys. It's going to be a special live tomorrow. And I might take tomorrow night off, but I think I'm going to work and do a special live tomorrow. It's going to be great. It's going to be great. Can we get 20 likes? Gosh. Sense of direction. I have a very bad sense of direction. Stephen, do you know why? What part of the brain is responsible for sense of direction? So you just said that your sense of direction is very good and you can get back to the same beach 5 years later. I am very bad at that. I am extremely terrible at sense of direction. North, south, east, west, I just don't know where I am. You should answer that, Poyo. Poyo and Steven, tell me, why is my sense of direction so very bad? But I have very good memory. I have good memory. Good job, Poyo. That's a great thing to do. Reading books. Awesome. You should keep on keeping on. Continue to read more and more books, Poyo. Very good job. I have a terrible sense of direction. Yes, so I park my car and I forget where I put it. And I forget which direction I had to go in and where I am, and I'll get off the bus somewhere and I won't know where I am, even if it's very close to where I have to be and things like that. And what is the thing that's responsible for sense of direction, do you think, guys? I could give people directions to a place, but use only landmarks, not street names. So I see. So you kind of remember what things were there, and you remember that, and you can give directions. I'm good at remembering things, like remembering names and numbers and things like that. I know direction well. Guys, I hope you're not making fun of Poyo with your Poyo comments. I do know about the ear stuff, Poyo. My question is more generally about directions, knowing where I am directionally. What are you saying? Make a YouTube short about Poyo. Yes, make a short about me. I just wanted to know if Poyo is ambidextrous. I know, Steven, you're a good boy. I know, Steven, you're a good boy. You're not going to make fun of a child. I'm a small channel. Poyo is ambidextrous. Pollo, short is coming for you. Don't you worry, okay? Keep telling me about the sense of direction question that I asked. I'm gonna share the live. Pollo, did you subscribe? Right, Kudu is also ambidextrous. Look at that. Yay! And so is the streamer I mod for. Let's see if I'm ambidextrous. Pollo says I did subscribe. Good. Maybe I'm ambidextrous. Hello, Giorgio. Good morning, very beautiful. The morning is beautiful. Thank you so much. Thank you. Welcome. Welcome to the live. Thank you for being here. This is the most intense live chat I've ever seen in my entire life. Really? Aww. Giorgio, thank you so much for being here. Can you please like the live? Can we get 20 likes? You should see it when Batman... There's a simple test I took when I was 8. Giorgio, can you please like the live instead of talking too much? I'm going to write something with my right hand now. It says super chat. And now I'm going to write something with my left hand. Let's see how this goes. It's a little slow. God, it's kind of slow. It also says super chat. Oh, Mike D. What the frick? Chickpea break. Have a good night. Seconds. Mike D, usually you're mostly normal. What happened today? Why are you being so extra weird? I cannot write left-handed and I tried. Chickpea Break, thank you so much for your mod contributions today, especially but not limited to timing out Mike D for 86,000 seconds. It's true. It's it is a very intense live chat. These are my two handwritings, right hand and left hand. Hope you can read both. It says super chat. Oh gosh. Mm-hmm. I see your comment, Pollo. Stop being so important. I see it. Oh gosh, I gave myself a dent on my face now. Pollo, are you an only child? Because you seem to have difficulty adjusting if I don't read your comments every single time. I was leaving, but I'm having so much fun. Ajnabi mujhko kaisa learner. Hello, ZZs. Why you don't read the comments out loud? You want me to read every single comment? Maybe comment something relevant to physics then. I forgot to share the live, but I will do so now. They're joking, Pollo. But Pollo, do you promise to watch all the episodes under the live tab on my channel? Go watch all of the videos. All of them. You will learn so much. You will become even bigger of a genius. Pollo is fun. Pollo is a fun guy. Are you a guy, Pollo? I will learn how to make a second alloy. Good job, Pollo. Yes, I am. Okay. Can we get 20 likes? dent I've given myself now on my face. Let me go back to sharing the live. You guys are really something. Maybe I should sing a song now. We recommend the lives for watching as white noise for sleep or studying. Very true. Sleep or studying, white noise. Here we go. Here we are. Steven's in the room. I bring in the fun with me. Aww. I had a friend at school that had 2 thumbs on the same hand. He told everyone one of them got chopped off by a door slamming, but we all know it was surgically removed. Why did he surgically remove it? It's okay to have 2 thumbs. With the occasional Baji. So your bro has a forehead headset dent. Got it. I'm gonna put my hair up. Enough is enough. What? What is a no-no? He was cool though, apart from his shirt was too big and his head was too small. Baji! Where is Baji? Let's see if Baji will come. Baji is lying right next to me. Baji has found a spot right next to me. That costs money, I know. Can someone do a $500 super chat for me putting my hair up? Because somebody actually requested that last night and we said it will cost $500. Dark Gloom, this is me. Baji's mom. Yay. Hello, Lucas. Hello, Lucas. Hello, Puyo. Hello, Reese, Steven, Chickpea Break. Baji's being good. Baji Baba is over here. Baji! Let's see if he'll come. Why are you watching the live on the live? I put my hair up. From my... You mean from my other phone? You mean from my other phone? Ooh, that's right. I was gonna sing a song. Do you guys have a song request? Ooh, you wanna see Baji? Baji! Baji's here! Baji! Looks good, thank you. Baji! Baji! I'm trying to encourage him to come up to my lap. Looks good. It looks like something. Here's Baji Bawa. Oh. Baji, show your belly. Baji, show your belly. Baji. Baji. No, that's Sachi. Baji. Baji lets me pick him up. Oh no, Baji. Sorry. Baji wants down. Sachi's the one who does not like to be picked up. Steven Spores, oh no. What's your song request? Go ahead. What's your song request? I just fell asleep watching the live, okay? Watching the live while falling asleep is highly encouraged. In fact, you should let this play in the background as you get to bed. Chickpea break. Do it! Chickpea break, do you have a song request that you want me to sing while you sleep? I can sleep, or not sleep, sing. That's better than I experienced. I was being studied from 4th grade to 8th. Abolish the IRS. One word away from the school spelling bee in the 8th grade. Okay. Hi, Baji. Hi, Baji. You want to sit down? You want to sit? You want to sit on my lap? Come. Come, Baji. Come, Baji. He's letting me pet him like this. I can't really play a song here because of copyright issues. It's a guitar song. Oh, Baji! No. Oh my gosh. Baji's gonna topple the water bottle, which has water in it. Oh, your nail is stuck. That's a good suggestion, Poyo. Thank you so much. Right now I'm distracted by Baji. He's on my lap and wanting many, 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 many pets and loves. So actually, we'll keep going. We will start with the wormholes and time travel chapter, and then we will finish it tomorrow. Good night, Stephen. Actually, we will just do this tomorrow. We'll just finish this, or we will start and finish it tomorrow. I'm tired. Yeah. Everybody's saying good night. If you want to say one last joke or something before you leave, now's the time. I'm going to say good night soon too. I gotta go to bed. I'm gonna go to bed. Baji's biting me. Baji's biting me. So yeah, I think we'll just continue this tomorrow. There I said a joke. No, Steven. Thank you, Pollo. I need to prepare for bed soon, but thank you. Thank you, Raikudo. Please do continue to play the playlists from my various live streams. I even had a live stream a while ago that was 6 hours long. I will give the watch hours on the accounts. I had hair in my mouth from Baji. I will give the, yes please Pollo, you should watch all the live stream episodes, continue with them, watch them constantly, and leave your comments under the videos and ask any more questions that you have on physics, astronomy, astrophysics, and cosmology that I can talk about in the future, that I can address in the future. Will you stream tomorrow? Yes. What's going on in Owen's world at the moment? Not much, just the same. Same. What about you, Wonder Boy? Everything good in the hood? Me and Wonder Boy have a love-hate relationship. I can see that. Pollo, I'll see you tomorrow. धीरे जलना धीरे जलना जिंदगी की आगे Blood tests. Is that from the fainting? How is the missus? Let me get my water bottle. turn off that very bright light. Oh my gosh. It looks very different when wait a minute. Do I have that bright light was on? But this is the lighting I use sometimes. These lights and these lights, and it looks so dark now. I turned off that very, very, very bright light, and it looks so dark now suddenly.